Hi, grade 11s. Today we'll be looking at the asymptote, the domain and the range of exponential functions. Recall that the standard form of an exponential function is like this, where q is the horizontal asymptote defined by an equation y is equal to q, y is equal to that value that are given over there. Also remember that if b is any number between 0 and 1, your graph will be drawn like this as a decreasing function. If b is a number which is bigger than 1, then it will be an increasing function. For instance, here, if b is, say for instance, is a half, or b is equal to 2 over 3, so it would be a graph like this. If b is greater than 1, for instance, if b is equal to 2, or b is equal to 7 over 3, or b is equal to 9,2 or something, the graph will be an increasing function like this. Another thing that you need to note, a can be a constant. However, if a is a negative number, meaning a number smaller than 0, therefore the graph will be reflected about that line y is equal to q. So if a is less than 0, the asymptote will still be there. So our asymptotes will still be where they are. However, the graphs will be reflected if a is less than 0. If we reflect it, it will be like this one here, and this one will look something like that. Let's look at some of the examples that we can get in an class exercise. For instance, they say here, sketch the graph of f of x equals 2 exponent x minus 1 minus 8. So we've got our asymptote. Our asymptote is the line y is equal to minus 8. So y is equal to minus 8 is our asymptote. It is our horizontal asymptote. We can straight away draw it. That's 0 to minus 8. I can draw it over here. That is a line y is equal to minus 8. The next thing that we know is that we've got to try and find the y-intercept. The y-intercept is when x is 0. If I plug in 0 there, it means that I have y is equal to 2 exponent 0 minus 1, then minus 8. When we simplify this, 2 exponent 0 minus 1, that's a half. A half minus 8, that is minus 7.5. Which means that our graph has got a y-intercept at minus 7.5. So we may say, for instance, we've got a minus 7.5 over there, minus 7.5. That is our y-intercept. Note that is our increasing function. So the graph will be going up like that. So it means that it will cut the x-axis. So it means that we need to work out the x-intercept. To find the x-intercept, we make y 0. So I make that 0. So I will have 0 is equal to 2 exponent x minus 1 minus 8. Take minus 8 across, I get positive 8 is equal to 2 exponent x minus 1. Change base, that's 2 exponent 3 is equal to 2 exponent x minus 1. I drop the bases, they are the same. So I've got 3 equals x minus 1. So solving for x, I get x equals 4. So the x-intercept is 4. So the graph will be cutting at 4, say for instance over there. It says an increasing function, so our graph will be going up like that. So if I may try and draw the graph to go like that, all the way up like that. That's our sketch of the graph. I've got the asymptote, I've got the x-intercept, y-intercept, as well as x-intercept. The domain at the x values allowed in the graph. You can see that graph is going all the way to negative infinite as well to positive infinite. Therefore, we can say the domain is x is an element of from negative infinite to positive infinite. What about the range? The range are the y values. You can see that the graph is always above negative 8. Therefore, we say y is an element of negative 8 to positive infinite, all the way to positive infinite, Okay, let's look at another example. Say in this problem you say sketch the graph of g at x equals minus 3 exponent x plus 1 plus 2 then plus 1. So what's the asymptote? It's the line y is equals to 1. So y is equal to positive 1. So I can throw that line straight away. Y is equal to 1. I can throw it over there straight away. So that's a line that y is equal to 1. Now, this was an increasing function going up, but now it's negative. This number here, the a value is negative, and we said when a is negative, it will mean that the graph will be reflected. So which means that our graph will be reflected somehow like this. So let's find out what is our y-intercept. We make x 0. When we make x 0 over there, so I'll have y is equal to a minus 3, and that is 0 plus 2, then plus 1. So y will be equal to. Note that the negative is not the negative of a 3. So it's 3 to the 0 squared, that's a 9. Then times a minus a negative number, I get a negative 9, then plus 1. So y is equal to negative 8. So the graph now is will cut at a negative. Y equals to negative 8. So negative 8, let's say negative 8 is over down there. Let's put the negative 8 there. Next, we want to find the x-intercept. Remember, the graph has been reflected like that. So the x-intercept make y 0. Plug in 0 there. So I'll say 0 is equal to negative 3, then exponent x plus 2, then plus 1. Take this across, is 3 exponent the x plus 2 is equal to 1. Now, I can change the 1 to a base same as this. So this is 3 exponent x plus 2 equals. 1 is same as 3 exponent 0. Now the bases are the same. Therefore, x plus 2 is the same as 0. So x is a negative 2. So which means that our graph cuts the x-axis at negative 2. So let's say negative 2 is over there. Negative 2 is over there. So I can draw my line, my graph coming down like this. So my graph will be coming all the way down. Now it's going to the y-intercept there. It cuts there. So we've got our y-intercept there, x-intercept there, and then our y-intercept there. So the graph approaches the asymptote. The domain. You can see that the graph is all the way to negative and all the way to the right. So therefore the domain x is an element of negative infinite to positive infinite. You can see the domain in the range, that the range is always changing, but the domain is always like this. Now what's the range? The range, you can see that the graph is always below 1, right? It's always below 1. So we can say that y is an element of from negative infinite, but you do not pass 1. Okay, or we can say y is less than 1. Let's look at another one. Could be the last one here. Say here, it says cache this graph here, but this looks like funny. So I've got to solve for y here because that's y over 4. We want y. So what do? Multiply this by 4, you get y. You multiply this by 4, this will 4 times this will give us a 2, then times 1 over 3 to the x, then plus 1. Now it's a standard form. So what is our asymptote? Horizontal asymptote is that line y is equal to 1. So y is equal to 1. It's our horizontal asymptote. Straight away, let's draw the line y is equal to 1. There it goes. It goes like that all the way. Then that's the line y is equal to 1. Then y-intercept. How to find y-intercept? X is 0. We make x equals 0. Plug in 0 there. So I get y is equal to 2. Then times 1 over 3 exponent 0 plus 1. So y is equal to 2 times any number to the 0, 1. So it's plus 1. So y is equal to, what do we get here? We get 3. So our intercept is at 3. So graph is cutting the 3. Say 3 is there. Now, this is a decreasing function because of a third, but you can check because you need to see that it's coming like this. Let's choose another point. In this case, let me choose x equals minus 1. If I put x as minus 1 there, so I will get y is equal to 2 times 1 over 3 to the minus 1 plus 1. So y will be equals to, when x is minus 1, so this would be 2 times 3 to the minus 1 with the minus 1 plus 1. So y is equal to 2 times. Now 3 exponent, now minus 1 times minus 1 there on top is 1, then plus 1. So what's our value? Y is equal to 2 times 3, 6 plus 1, that is 7. So when x is minus 1, so the point that you get is that minus 1 is to 7. X is minus 1, then to 7, says to 7 is over there. So we'll have our point there, minus 1 to a 7 over there. So the graph is obviously coming down all the way like this. So the graph is coming down all the way there and approaching the asymptote. There we go. Next one now is the domain. How to find the domain? The domain, to check the x values. You can see that the graph is on the left and towards the right. So the domain is x is an element of, it's negative infinite to positive infinite. What about the range? You can see that the graph is always above 1, y equals 1, is always above 1. So therefore, you can say y is an element of, there is 1 to positive infinite. Then, ladies and gentlemen, if you can try your own problems from Siavula textbook, your grade 11 maths textbook. Chapter 5 says functions. You do 5.4 on exponential functions. You do exercise 5.15, exercise 5.16, exercise 5.17, and exercise 5.18. Although some they don't say sketch the graph, it's easier if you can see a graphical representation of the problem that you are asked. So if you can try those, that'll be better for you. Good luck.